All right. So hopefully you have your lab math good. Thumbs up if your math, you're done with it. One. Raise your thumbs up if you're done with the math for the lab. Okay, if you're not, do that over the weekend, because on Monday we're going to mass. We're going to find our actual yield. The math is your theoretical yield, and then we're going to use that to calculate our percent yield. So make sure if you aren't done, let's get it done. If you need help, come Monday morning or during beat time, we can help you out with that. Okay, the last two pieces of chapter 3 are finding empirical formulas and then combustion analysis. They both require math. I love that you love it, even though you were sarcastic. So there's nothing like crazy that we're about to do, but we can find an empirical formula from the percent composition. Davis, I'll take it. Thank you. The test tube should be right here in this. I know. All right. Don't write this problem down. Let me just talk it through and we'll do it together. But like, you don't need to write this sentence down. But the compound para-aminobenzoic acid, you may have seen it listed as PABA on your bottle of sunscreen. It's now banned, by the way. They found out that this kills coral. So you can have it in Utah, but it's banned in ocean states. It's composed of carbon, hydrogen, nitrogen, and oxygen. Find the empirical formula of PABA. All right, why are we starting with one that's so hard? It's not hard. It takes so much work. I don't know where the easy ones are, so we'll just go for it. Okay, when you are given a percentage and asked to find the formula, it's a pretty simple thing. It takes time, but it's pretty simple. The first thing you do is convert percentages to grams per 100 grams of the thing. Now that might not make sense, but it really is not bad. So you look at this problem, we make an assumption and we know it's percentages. We say, all right, I'm going to assume I have 100 grams of it. All right, if I sit here, all right. So if I had 100 grams of PABA, then math-wise, 61.31 grams of it would be what? Be carbon, right? Are we okay with that? So when you're given percent, just assume that you have 100 grams of the thing, and then that percentage becomes the grams of how much carbon you have. It would also mean you have 5.14 grams of hydrogen. Tell your lab partner, how many grams of nitrogen would you have? Thank you, lab partner. 10.21 grams of nitrogen. Now, everyone look at the screen for a minute. This is a little bit tricky. Up until now, we've always said hydrogen and nitrogen were diatomic, right? We do not do that when we're finding the formula of something. We only do that when they're alone, but they're with carbon, hydrogen, nitrogen, and oxygen, okay? So on these, just put CHN, and then we have how many grams? 23.33 grams of oxygen. All right, you don't have to, but that would all add up to 100 grams because I said I had 100 grams and this was the percentages. Okay, so step one, convert the percent grams out of 100. So you just basically put a gram sign here instead of a percent. Okay, Number 2, divide. Uh-oh. No one was injured in the filming of this video. All right. Divide each gram by the molar mass. Okay, so follow my logic here. I'm going to take 61.31 grams and divide it by the molar mass of carbon. The molar mass of carbon is 12.011. You're like, wait a minute, you've been rounding every minute. You can round on these, and I will, but on your tests, I would be really accurate because when you round, things don't work out perfect. All right, someone divide 61.31 by 12 for me. Okay, I already did hydrogen divided by 1 because I'm really good at math with ones. What's 10 divided by 14? And tell your partner real quick. I know you know, so you have to tell me. Where does the 14 come from? Am I just making that number up? It's the big number in the N box, right? It's the molar mass. All right. So 10.21 divided by 14 equals a number. All right. And 23 will be divided by 16. Perfect. Okay. Now, what I just did is I found the moles of each part of this compound. Okay, look real quick here. You don't have to write this down. But if I have like, I'm just making this up, but let's pretend it's C5H10 NO2 or something like that. These 5s, 10s, a 1 and a 2 means I have 5 moles, 10 moles, 1 mole, and 2 mole. You okay with that? Okay, so I'm sort of closer to the formula. There is a third step, and it's going to be ugly, but I'm going to write it down here. The third step, divide all answers by the smallest answer. You guys ever put on a pair of socks and halfway through your day, your big toe tears through it and you just have to live with that hole in your sock all day? That's my day today. Thank you for your compassion and empathy. Okay, so divide all answers by the smallest answer. So I just come up here and I look, and which one of these 4 is the smallest answer? 0.729. Oops. This will equal 1. This will equal 2. No, I don't know these, but they're going to be around the same answer. .995, good. Then this one's going to be really close to that. Okay, and then we're just going to say 1 and 2. All right, now, my friends, these answers, they must be very close to a whole number. And then I'm going to put a little asterisk right here because they don't really have to be, but for now they're going to be. Is 6.995 close to a whole number? Yeah, that's really what a whole number? 7. And if we had used 0.001 and kept our calculator going, it probably would have been even closer to a perfect number. This number, pretty dang close to just 7. This one is 1. This one, I didn't type it, but it is super close. It is 2, isn't it? It's dead on 2. Okay, so what these are right here, what we just solved for are the subscripts of C, the subscript of H, the subscript of N, and the subscript of O. So I now know my formula is C7, H7, NO2. That's not awful, right? We've done a lot of crappy crap, and that one's just not even hard crap. Now, if it's not a whole number, then it better be close. How do I put this? Okay, just stick with me for a second. These answers, 80% of the time, are going to be nice and clean whole numbers. Once in a while, though, you'll get like 2.3, like right here. And 2.3 is just not close enough, right? So this gets a little tricky. If all these are whole numbers, but this one is a third, then you multiply every answer by 3. And that makes this 2.3 times 3 is what? Is it 8? 7. You're right. It was 7. And then that'd be a 3. That'd be a 21. And that would be a 21. Those are tricky. But if it's not roundable, you have to take whatever it is and figure out how to multiply it to make it end with a 0. And this would have been like 3, 3, 3. Okay. I need another example so we can rock this. Where are they? This has got to be the wrong slide. Hold on. Because I know. If you used the exact numbers off the periodic table and you got a 0.2, you should multiply by 5. It's really rare. Usually it's just a half. So if one of them is like 1.5, then you double every number. And then 1.5 becomes 3. It's usually very cut and dry on that one. I know I have better examples. Just give me a second. Here we go. I opened up this 2 years ago, almost to the day. Okay, here we go. This one's short, but it's the same process. A compound is found to be 50.05% sulfur, 49.95%. Whatever. I looked away. Oxygen, probably. There you go. All right. I'll give you a minute and 15-second head start. Then I'll just do it, but just don't look at the screen. Or yeah, just look at the screen and let me do it for you. Oh, this is easy.
We need to know the weight of the compound.
We'll talk about this in a second. That is the second piece. All right. You concur, lab partner. Yeah. You're very smart. All right, how many of you have that answered? Raise your hands. Okay, this would be like the most simple one you could ever get. 2 compounds. The math works out pretty good. So we converted both to grams, then divided those grams by their molar mass. Then we got 1.56, 3.12, divided by the smaller of the 2 answers, you got a 1 and a 2. Okay, this piece right here, this is on almost all of these type of questions. In this problem, the way we're going through it, we can only find the empirical formula. And that was a definition from like a month ago. The empirical formula meant the lowest ratio. So like a 2 to 1. But in molecular compounds, sometimes it might be S2O4. So you'll have this secondary piece that says, hey, the molecular weight of this compound is 64. So what's the molecular formula? The molecular formula is the real formula. The empirical formula is the formula of the lowest ratio. Often they're the same. And in this one, so what we would do, we'd say, all right, well, this is 32 plus 2 times 16, and that's 64. If this formula matches that mass, then the empirical and the molecular are the same. One more time. If the formula you find, if its mass adds up to be the same as the molecular weight it gave you in the problem, then the empirical formula, which is SO2, is the same as the molecular formula. Now, let me give you an example of what we're talking about here. An empirical formula for sugar is CH2O, but its molecular formula we know is really C6H12O6. But the process we just did, it would only tell me the ratio is a 1 to 2 to 1. And so, but then, so you would know it was CH2O. Then the problem would say the molar mass of this substance is 180 grams. So you'd be like, all right, well, this adds to 12 plus 2 plus 16. Whoops, that's a plus sign. All right, and that equals 30, right? Okay, so this is how you do it if they don't match. You take the big number and divide it by the smaller number, and that will be 6. That means each part here is multiplied by 6. 1 times 6, 2 times 6, 1 times 6.
That was always be like a whole number, right?
Yep, these will never be fractions or decimals. All right. Okay, vitamin C contains 3 elements. Take a picture of this and try it, would you? Here's the second piece that would be asked. The spacing's kind of weird. You have C, H, and then O. Sorry, the spacing's weird. Well, you can start. We're just out of time. We have 1 minute and 11 seconds, I think. It's nice of Blaine to always leave me a seat.